So let's continue where we left off last week. So the admin still hasn't given me the schedule for the missing 1 hour due to the power outage. Hopefully this week they will give us some news. All right. So yeah, we still have a lot of things to catch up. We have to finish the control structures. After this, we go to functions. And after functions, we discuss objects and classes. After that, we can go directly to um, data science proper. Right? We're going to use libraries, we're going to learn how to install them, how to use them, their applications, and so on and so forth. But everything depends on our foundation in Python. So, yeah. So this is our third session. I'm hoping we can finish everything today. Let's see. Actually, yeah. So there are some parts in the PowerPoints where it's not really that important, right? So we're gonna skip some details or sections in the PowerPoint that you know that's just extra knowledge that comes in handy, but not from a foundational standpoint, right? So we'll skip those things, and if we still have time, we'll go back to those. If not, I'll leave it as your working assignment, right? Or something that you can read in your free time. Okay. But again, nothing beats practice. So it's always better if you go and look for practice exercises for Python. Um, there's a lot of it on the internet. Just do a quick Google search. There's a lot of it. Most of them have solutions already with explanations, so that's good. If you want something like you can do maybe 30 to 1 hour a day, there are sites like not the name. Oh yeah, this one. So we're not advertising this, but this is just one of the things that I used before when I started out programming. It was a long time ago. Now I don't really use this one a lot, but it's good for starting the habit at the beginning. Um, yeah, so you can go to the site, just register. It's free, and then they have this kind of like a challenge system like this one. Kind of like you're going up the ranks. You choose your language, and then you start with fundamentals, and then you can choose if you want to start this way or proceed to um, different sections, or if you want it to be randomized, that can be done. So, yeah, these are real questions made by real programmers. At least that's what's advertised. But when you get to the higher levels, it gets really really complicated. That it takes more than an hour. But from my point of view, when you reach that point, you can be sure that your foundation in Python is already solid. So you don't have to finish everything. Just make it a habit. Get that programmer mindset going. That I always say this to my students, but programming is a skill, just like any other skill. If you are not using it, then odds are you're gonna forget about it. Even if you've memorized everything or you've learned everything before, if you're not gonna use it, then you're gonna forget it. So make sure to practice. All right. Now, where did we left off last time? on this one, it was. Oh, yeah, I was trying to explain the um, way that for loop works in other languages. Um, yeah, so it might look like the for loop that we've learned has no like condition, right? Because we just give it something to loop over with, right? An object it can loop over with, um, and then that's it. At the end of the file, it's done. But ideally, underneath that, right, there's actually a condition, and the condition is keep on accessing those pieces of data inside the container one by one until you reach the end. That's the condition. You can change that condition anytime using this format in other languages, but in Python, it's not that it's not that readily available. So you have to uh, find a loophole for that one, right? So that's what I was trying to say last time before I was cut off with the power outage. Now, after that, we were supposed to go to the second way of mm, second way of not that second way of looping. Um, how to say this? Looping format. So one is the for loop, right? The other one is the while loop. Right there we go. So for the while loop, it's called the entry level. I think we're done with this page. All right. Okay. So was I able to demonstrate the while loop here? No. All right. So let's use this one. The syntax for the while loop is rather simple. You start with the while word like this one, and then you follow it with a condition. So the condition here is data data is not equal to blank. Right? Now what is data? Data is a variable, and what is inside that variable? It is the program asking an input from the user, right? And with a prompt, it will ask the user, or it will display to the user this question: enter a number or just enter to quit. All right. Now the program is actually very simple. It just says keep on repeating these lines of code until the user will just press enter directly without any text or any kind of like space number until the user has entered that um, input, right? The loop will not end. Okay, so until it detects that there is nothing right on the input, the loop will not stop. So essentially, it will keep on having this kind of output. So you can see that we input 3, 4, 5, and then enter a number or just quit. Okay. Now there is a loophole in this program because we say that data is not equal to an empty string, and then our question is enter a number, but we had actually no way to check if um, the user did input a number, right? So that's why we have um, this one here. So number is supposed to float data, right? So at this point, we converted it, right? So we converted it directly, assuming that the user has entered a number. But if we did not enter a number, this is going to return an error and it's going to crash the program. It's asking another input here inside. Why? Because this is where the code will be kept. Okay, it will not go back outside of the loop to ask again. So we have to put the question inside and assign it to the same variable again so that it can be used or edited. Um, the variables content can be edited, right? So yeah, that's why we see this one appearing here a second time. And of course, after that, it's gonna have to print the output. That's why we see this one here. So it's not really that evident because the code is kind of flush to the left, which is not really ideal in this case for this PowerPoint. But you know, they must have forgotten to put the tab here, right, to make it less confusing. If we try that one now here, right, as a proof of, just to show you guys that the code actually works. So it's asking for what? Data is equals to input and then number or blank, right? So that's what it's asking. And then we check if the data is not equal to blank input. Alright, while it's not equal, it's gonna have to convert it, float data, and then we're gonna have like sum, right? The sum. We can't use sum because sum is a function. See, it turns green. So it's kind of modern IDEs have color coding by default. So anytime that you put a function, the moment that it recognizes the name as a function, it's gonna turn that color into that assigned color. So in this case, it's green. There's a lot of color schemes out there. It's really up to you what you want. But you know, the main point here is not the color. The main point here is that as you are typing, you will immediately see if the word that you are using is also recognized as a function. So when that happens, Python doesn't know what you're trying to say. Are you saying the word, literally the word sum, or are you saying the sum function? Are you, or like you're telling Python to use the sum function, right? So that's what it's called. We're using the sum variable here. After that, what are we gonna do with the sum? We're gonna add the number itself back to the total variable, the sum variable. What this essentially does is it will just keep on adding the numbers, right? What did we do next? We asked the user again for the same thing, right? Why did we ask the user for the same thing? It's because we are now inside the loop. So we have to find a way to change the condition while we are inside of the loop, right? Otherwise, we can't really escape out of the loop, okay? Although the program will pause because we're using an input. That's something that will happen when you're using the input function. The program will literally pause because it's waiting for an input from the user. Alright, now after that, we were gonna print, right? So print, what will we print? We'll print I'll just say the sum is space and then the sum. Something like that. That's it, really. So let's show the line numbers. View. Here we go. Alright, so it will, the while loop, alright, starting from um, line 2 up until line 6. It's gonna keep on looping that section until the condition is false, right? Much like the for loop. The difference is that the for loop has to loop over the smaller pieces of data that is contained in the container. So if the container is a data structure like an array or an object, which means that it has even smaller things inside of it, then um, that's what the for loop will use, like how many times you have to access each one. This here, while loop is again can run infinitely forever, so it's good for um, things like you always want to keep checking, or uh, maybe a simple counter. You can do a while loop with a simple. All right, so what is the expected output? We'll see the numbers that we keep on inputting being added one by one, and then we're also shown the sum at the end, right? So let's run this code, enter a number or a blank. So if I put 5, okay, I made a mistake. It literally saw the input as nothing, so that's why it ended. So we know that if you enter the key directly and press enter directly, it will just end the program. But if you enter 5, let's see. Wait, the sum is not defined. Why is the sum not defined? Alright, so we forgot to declare this one outside of the variable needs to exist first outside of the loop. So the sum is equals to 0. We run this code again. Fine. Alright, so the current sum is 5, that's correct. If I put 8, that would become the sum is 5. It's not adding up. Why is this not adding up? Okay. 5, 13, 18. Alright, so at the beginning we input um, data is equals to 5, right? And then we um, wanted to see the value of data, so that's why 5 is here. After that, it goes back to the top. This time, let's see. We are being asked for the input, so we answered 8, right? After answering 8, what happens? It goes directly to this one, line 8. It goes directly to line 8 and prints the current total that is being added on. Okay. As the loop keeps on going and going, I'm gonna add more stuff. So eventually, there will come a point where you have enough, so you have to end it. So all you have to do is just enter a um, blank answer in the input field, and then it will end. All right. So I think that's it for the while loop. Again, the one that's used a lot, more used is the for loop, because it's easier to understand. Right? I mean, both of them are easy, but if this is your first time, then it might not come off in a straightforward manner. Alright. Now let's see here. Count control with a loop. Summation with a for loop. Alright, so basically it's just comparing the two codes side by side. Okay, so the one is a summation done with a for loop, the other one is a summation with a while loop. So meaning there are multiple ways to answer the one I'm asking for here, right? Let's see. So for count and range, it's gonna count from 0 to 10,000, right? With 10,000 included, that's why there's 10,000. So remember, this is in range. The next one here is just adding it back to the original, the sum variable, and then print the sum afterwards. Okay, let's see. Mm, we go about this. Mm, change. Alright, so let's discuss about the break concept. Right? Now, the break concept here is something special that we can use in while loops, right? Not just in while loop, but for any kind of loop, really. It can even be used inside of functions. Now, how does that work? How does the break work? Now, the break works by when the code reaches that point, it will automatically stop. Okay, so uh, that's the purpose of the break. Okay, now if there is a break, there's also the opposite, which is continue. Okay, so break and then continue, right? So these two, and yeah, these two are fairly common, especially when you're trying out practicing Python. In some solutions there, uh, let's see if they were actually, you know, swapped together. Let's see. Let's have an example with break. So let's go back here. Let's say I want to put the condition inside where if the sum, right, is greater than 10, what I want to happen is that it will end, right? The break here will break the loop. So the moment that the sum is greater than 10, yeah, let's see what will happen. Oh, there's a pending input. Okay. All right. So 4, 5. What happened? Okay, hold on, guys. All right. Okay, this is what happened. So 5, 4, 3. Greater than. Let's see. What am I missing? Okay. 5, 4, 3, 2. Alright, so 5, 4, 3. That was the output, right? Alright, so 5 plus 4 is already 9, right? So the moment I add another number, it will automatically detect that it is greater than the number 10. So, let's see, 5 plus 4 is 9 here. Hmm. Let's chase. I don't know. Let's see. And the input. So the initial sum is 5. After I add 4, the sum is equals to 5. Hmm. 4. Alright. Let's trace the number again. I think there's something wrong with the logic here. We converted the number. We added the number to the sum. So the sum here should be 5, right? Is 5 greater than 10? No. So it skips this one data. It will ask the user again for an input. But it's not really. I think I'm missing a line. Break some number of floats. Right, this one. That's correct. Number or well, data is not equals to blank. Okay, it's asking twice, which is correct. Ask once, ask twice. The problem is data input is equals to data. Alright, so I put another 5 here, or a different number, then it should be added to the total sum. I think there's something wrong with our sequence here. How about you guys? Do you spot something that's wrong with the code?
So I'm doing the code right now, and this is the one that I did. I'll
Mm-hmm.
just do it.
All right.
What
Can you share your screen?
can I just send it here? I'm not
Oh,
sure.
okay. All right.
Let me
There you
just
go.
myself.
So let's see the solution of velocity. All right. Let's try and copy this one. All right. All right. So input. Let's see. So five. The sum is 5, 4, 9. And then if I add one more number, it's gonna be greater than 10, right? So after that, it should exit out. Alright, this is correct. Now, what was I missing in my code? In my code here, the input was ask after the check. In Felicity's code, the input was ask first before adding it to the sum and then printing it out. Alright, so that's why it was something like this. Alright, good job, Felicity, for spotting that one. Alright, so that is the only problem, the sequence of how we did it. That's why it was appearing twice here on my end. And then um, we can't really see how the numbers add up before it got cut off. So that's what I wanted to show at here. It's exactly shown properly. So 5, 4, and then after I add 2 here, or input 2, it's gonna go about 10, and then it will break. So good work. Okay, so that's the purpose of the break. When you have like you want to introduce like an exception or another condition to already uh, a check in the while loop, right? So we were what checking for an empty space. But if you want it to check for something else, that it should also like exit out if this is equal to that or this is less than a certain breakpoint, right? You can add that one and then just use break. So the purpose of the break is to cut the current iteration and go directly to the next line outside of the loop. All right. Now the opposite is also true. It's just doing the opposite thing. So it will just continue, right? How do we do this? So continue. If we replace that one with continue, what will happen? So we input the number is converted into an actual number, it's added to the sum, and then we're gonna check if the sum is greater than 10. But in this case, I'm gonna try and say, when do I want to continue? So I want it to continue whenever, like, um, whenever the sum, let's see, maybe not the sum, or like I want to skip inputs of, let's say, 5. So if data is equal to 5, so whenever the user will input, oh no, not data, because that is still a string. We're checking for a number, so we're gonna use num, not data. We're checking if whenever the user input is at 5, it will just continue to the next iteration. So on the next iteration, um, let's see, on the next iteration, equals to 5. So I want anytime that 5 is used to skip the addition. So if I wanted to skip the addition, I have to move this one below the if category out of the if or statement. Let's try this one. Okay, so 4, 5, and then another 4, and then so that's 2, right? Um, let's try add 8. All right, so it's adding up correctly, but every time I put 5, it's not gonna add something to. Oh wait, there's an error. Yeah, so this is what I mentioned earlier. Since you're using float directly on the user input, um, you did not check if um, what data type was right. So it will return an error like this if they did not match. So the float function is looking for a numeric value. It's not looking for um, the other value. So let's see. Num5. Okay. So the moment I enter 5, right? Anytime I enter 5, it will just continue and go back to the beginning of the stage and ask the user for an input, right? Um, yeah, I think that's all there is for control structures. Let's see what else do we have here. Boolean variable. So this one is just a different way of using the while loop. This time it's using the not done function. Oh no, not, and then done here is the variable. All right. Let's see. Asking the user for a number. If it's in between, then that's true. If not, it'll print out the grades must be between 100 and 0, and then just echo the valid input. Alright, so that's just a quick check. If the user actually entered a number that is within the scope of the current problem. Alright, so we're at the point now where we are seeing methods, random numbers. So random models plus so this range returns random number from among numbers between two arguments included. Alright. Let's start first with the description here, or this part. The one that says random dot rand. Okay. Now the important thing here is the dot. Alright, the one that separates the first and the second word. Okay. So that dot actually represents you are trying to access something, right? Um, you're trying to access something inside of random, and that something is called randint. Okay, and randint needs two pieces of arguments. So that's 1 and 6, right? And this is everything is printed out. So as you see, the numbers are kind of predictable, but what they say is that uh, nothing is actually that accurate in making things random. So there's a way to actually get the sequence, but it will just take a very long time. All right. Let's see what else we I think these are the finishing touches of the PowerPoint. We're at the ending part now. Chapter summary. Alright. Yeah, I think we can skip this one. Besides, it's just a summary of what we do. Okay. Let's have a quick activity. All right. Um, encompassing everything we have learned so far, starting from print up until to this point. All right. And uh, we're not gonna take that long. Um, but we will solve it together. Okay. So actually, it's a very simple exercise, one that's repeated a lot in many tutorials, whether it's online or in the school. This activity is good because, like I said earlier, it encompasses a lot of the lessons packed into one. Okay, so it's actually very simple. I want you guys to make a calculator using mm, text-based display. Display. Alright. So the instruction is very simple. Make a calculator. Create a basic calculator that allows you to perform not the hard functions, not the hard operators. Just a simple one. So MDAS, addition, subtraction, multiplication, and division. Um, and just limit yourselves to two numbers. So that's MDAS, right? Two numbers. Let's see what else. Let's see. What else can we add? Mm, all right, I think that's it. It's up to you guys how you want your program to work. You can go and use the input, right? And then you have to manually convert them, or you can assign them directly to variables and then use them up. Um, let's see. The output, right? Since we're still using Python, the output will show here, right? Our calculator must be able to, let's see, perform multiple operations. Mm, and then, like this one, it also has to quit, but you can quit the program when it enters a specific uh, key. So, like for example, the letter Q, it should exit on letter Q if you input letter Q. Yeah, something like that. All right. Um, let's see. How many minutes should I give you guys this one? I guess 15 minutes is enough for this. Again, just focus on the basic operators: addition, multiplication, subtraction, and division. Right. Once you understand how that works, all the other operators are just basically the same. Okay, you're just gonna have to go back and forth and copying 15 minutes on the clock. It's currently 2 here on my end. I'll check your work on T15. You guys are free to use Google to search for answers, but odds are um, you're gonna see both. You're gonna see very complicated calculator solutions and some very simple ones, right? If you find something that's in a different language, that's okay. You can just try and read it out and understand what they're trying to do and translate that one to Python. All right. So yeah, 206, 215. I'll check your work. All right. Okay. So let me know if you have a question or you need something. Oh, let's see. Nick is already done. Okay, let's give the others a chance to do the activity as well. Right. Try to let's see. Try to understand the code, right? And then maybe I can ask you some questions later on. Try to see what was their way of thinking when they were programming that. All right. Okay. So yeah, I'll be here. Let me know if you guys have any questions.
tingin. Okay, may tingin?
All right. Is everybody done? So far, I think. I mean, Nick, how about the others? Do you need some more time? All right. So, Felicity is done. Okay, let's check first the work of Nick. All right. So, kindly share your screen, Nick, and then give us a short explanation on how your code works.
Um, window. Can you see my screen now?
Yes, we can see your screen. All right.
Um, I really don't know how to explain it because I don't have a background, but what I can understand is the code that I found uses the while true uh, arguments, and then the function basically says the code basically says to choose an operation on the first line, and then requires you to enter which operation to select, or either exit, and that stops the entire code, or proceed and go and select a specific operation, plus, minus, multiplication, division, um, and it functions using it can compute 2 digits, so it will require you to enter the first number and then the second number. After that, the results will be displayed.
All right. Um. Okay. So you're using. All right. So plus and zero.
Let me just share
Can
it
you
on
can you
chat.
try
So,
and run the can you try and run the code?
YouTube.
Oh, I think you have to stop it first. Exit again.
Okay.
Yeah.
This one.
Yeah. All right, and then run the code again. Enter the operator. All right.
Okay, so select operator. Let's say multiplication. That's what I did earlier. So 6 for the first number, and then 5. So the result would be 30.
All
Sorry,
right.
I can't really dive into this because I'm just really newbie in
That's okay.
in coding.
Yeah,
Okay.
that's okay. Um, but were you able to understand at least the flow of the program?
Yes.
Okay, that's
So
good.
yeah, basically everything was defined on this part,
Mm-hmm.
since it assigned the specific functions related to the first part for the print function selection,
Mm-hmm.
and then the um, number of entries would be here on this part.
All right.
So this two, I think, is the main uh, body of this code.
All right. So, why do you think? All right. Let's see. Why do you think um, it was asking for the choice is equals to exit in the beginning.
In order to determine which operation, mathematical operation, it would be doing addition, subtraction, multiplication, or division.
Right? Or whether or not the user will want to continue. Right? Can you run the code again, but this time I want you to input a letter instead of a number.
Okay. Mm,
All right. So there is an error, right? Can you go back up? Okay. So
So it's here.
yeah,
It's this one, right?
yeah. So
First
you entered, you chose a um, an operator, but then you input a letter, but the function is asking for
for a
uh,
number.
yeah. So at that point, it will return as an error. So that's one thing that we can improve with the program, right? But again, although we haven't gotten to that point yet, but it's good to know um, that you have to think of all the possibilities that the user will
Oh yeah,
enter. Yeah. So
I haven't considered letters
yeah.
would
So
return
yeah. So there
errors.
is
Okay.
actually a small part in your code that handles errors. So it's actually in the very beginning. So can you go back up? It is when none of the operators you input is in the choices. So can you try and run again? But this time I want you to uh, choose a different operator, like the percent sign. So try and run the code again, but choose the percent sign. Yep. All right. So it says invalid input, right? Now, as you can see, the program did not stop abruptly, right? Because we had a way to control invalid inputs, right? Whereas
Okay.
earlier, you entered a letter after choosing an operation, it returned as an error because Python did not know what to do at that point. All right. Okay. So thank you
Okay,
for
so
sharing.
it's this one. It's this one or
No,
exit
it's the
or
second
no.
if. It's the second if. The first
Oh,
if is
okay.
just
So this one
asking if it's exit. So if you enter, yeah, try entering a different, let's see, choices input is it was input operator, right? So in the very beginning, you're immediately asking what the operator or what operation you're going to use, right? But first it will check if it's an exit. If it's not exit, then it will check the operation. um,
Oh,
yeah,
okay.
so it has to check
Okay,
first
okay.
if it's an exit, otherwise it will get confusing. Okay.
Okay, okay, I get
So
it.
thank you for
Okay, thank
sharing.
you.
All right, so that was a good um, example of code, but again you found that one on Google, right?
Yeah, I
All right.
didn't write it.
Okay, that's all right. It's perfectly normal for programmers and developers to copy and alter code that was made by someone else. That's the main
Yeah.
point of programming. It's modular in a sense because we use the programs made by others, the libraries used by others, so that we don't have to do them ourselves, right? Even Python itself, right? We just use the functions directly print, right? But underneath that one is very complicated. You have to access different things. You have to know, um, like I don't know. Even I don't know the deeper parts of programming, right? But um, we know that if we understand how to use the function, right, we can actually get something out of it, right? So I always tell my students this one, like compare it to driving, right? Whenever we're driving a car, so what's the real purpose of us driving a car, right? So we learn, right, the basic things only. We learn how to use the wheel, use the they call it one, the the gas, the brakes, the basic maintenance. We need to learn how to what the rules on the road, um, the gear shifts, right, or the clutch if you're using an older car. So that's the only thing that we need to learn, right? We don't need to be a mechanic. We don't need to understand how fuel injections work. We don't need to learn why. Um, what is the correct ratio of air to gas in order for the piston to go up, right? Up and down, and then turn the crankshaft, therefore generating electricity, charging the alternator, and then giving power to our car, right? So I don't know about you guys, but maybe most of those things that I said um, might be new to you guys. But again, you don't need to know that one, right? In order to drive a car. Your main purpose of the car is to what? The main Your main purpose of the car is to use it's its function, right? To take you from point A to point B. That's what we're trying to do with Python, right? We don't need to learn the deeper parts, right? Just enough so that we can understand and explore more things. Later on, if you get, um, you know, uh, really comfortable with programming, so you won't notice, but you'll try and dive deeper by yourself. So that's good. I think Felicity also has an answer. Is your solution a bit closer to what Nick has, or is it in a different format?
Mine was mostly from what I remember from what I learned in school.
All
But
right.
the thing is, we didn't learn about Python. We learned about C, so
Yeah.
I
Okay,
just
that's all
had
right.
to
Can you
search
share
up
that to
some.
us?
Yeah, sure. I wanted to turn it into a while loop, but I just forgot to.
All right. Okay. So this is from Felicity's work. Let's see. Right. So the only. All right. Can you scroll up?
Scroll up.
Oh, that's the whole cell. Okay. So it's not in a loop format. Yeah.
Yeah, yeah,
All right. Okay.
yeah.
Input. All right. Does it work?
Ah, yeah. I tried it earlier.
Okay. All right. Okay. So technically, it's in the same format as Nix. Um, the main difference between yours and Nix is that the sum here, right? You are creating a different variable entirely for the output of each operation. So you have sum equals x plus 1, you have diff equals to x plus 1, right? Product is equals
Mm.
to x times y, and then division, which is quotient, equals to x divided by y, right? So this is what I said before, right? That just focus on making it work. And this is actually a good example because it works, right? But there's a lot of ways that we can improve this one, right? So you can see some repetitions of the code that we can actually reduce the number of lines, but that is perfectly fine, right? Since it's you did it yourself, that's perfectly fine. Um, let's see what else can I see here. That's different. So you have no way of checking when to stop the program. Is there?
No.
No,
It
right?
just ends for like if you do one.
If you one, all right, it just ends. Okay. Um, let's see. Invalid operation. Can you try and make the output display invalid operation?
Which one? Which one?
The last option. So try
Okay.
to use a different, maybe use the percent. Yeah, like that. Okay, invalid operation. All right. So let's see. All right. So technically, it's in the same format as what Nick had um, earlier. So the main difference is that there are some lines here that we can reduce, you know, and instead of creating more variables, we can just put the operation directly inside the print function. So that's one thing. Um, let's see. You can also, instead of putting the x and y repeatedly in every condition, you can just ask for it once and
Mm-hmm.
then just go directly to the operation. Uh, yeah, just put the operation directly in the printf, in the print section. All right. So thank you for that, Felicity.
Mm-hmm.
Okay, so let's see. So I guess that's just it for the activity. Let's just stick to one. I just wanted to check if you guys were able to understand the topic, right? So that's good. All right, we're done with this. Okay, let's let me go to the next PowerPoint. All right, text and strings file, strings and text files. Okay. All right. So in this section, we'll examine the internal structure of a string more closely. We'll learn how to extract portions of a string called substrings. All right. Now the concept here is um, like I want you guys to look at this more like a container, and then inside the container are smaller pieces of containers, right? So it's a big data, and then inside are smaller pieces of data. That's how I want you guys to think about this, right? Because that's how actually data, right, is stored on different things that you see on the internet, like user accounts, passwords, databases, right? That's how they operate exactly. Okay. Now let's start with the structure, right? Or actually, let's start with the len. Now the len function, right, returns the string's length, which is the number of characters it contains. Um, this is not exactly the correct description, but it fits to what we are discussing right now. The actual function of the len is to return how many smaller pieces of data there are in a data structure, right? The string is a data structure. See, string is a data structure. It consists of smaller pieces of data. The smaller pieces of data are the letters. Okay. The string's length is the number of characters it contains, right? So in this case, the string I there, right, has the number nine when you use len on it, because there are nine characters. So one, two, three, four, five, six, seven, eight, nine, including the space and including the punctuation mark. So there are nine characters overall. Okay. Now, if you expand this idea further, right? Let's expand this idea further. So from a string, right? Let's expand this one. Let's say you have um, user data. Okay. So the entire container is user data. Now, inside this user of that user data, you have name, first name, middle name, last name, age, right? Address. Each one of those is a smaller pieces of data, smaller piece of data. Okay. Um, Patricia. Oh, okay. All right. Okay. So this approach, all right, it's a roundabout way, but yeah, it's still correct. So good work on this. So you're asking the user kind of like a traditional method, right? Like how we do it in the old ways. Instead of asking for the actual operator itself and then accepting it as a string, um, you're asking the user to choose, but they have to input the number. Depending on what number they choose, um, a different operation will be selected, right? So this is a very old way of doing it. You can see this one in a lot of MS-DOS, in older versions of Excel, in older games. When you have to choose a certain selection, um, you often have to choose by typing out the numbers, right? Or even letters. Actually, you can say A for addition, B for subtraction. So yeah, this is good actually. This is a good code. All right, thank you for sharing this one. Pretty sure. Actually, can you also send this code to the chat, not for everyone to see, so that they can also compare their code to what you have, right? So that everyone can see that there's a different way of actually asking for it for those operations, right? Okay, thank you. Right, so let's get back to strings. Okay, so if you expand that idea, right, you have a bigger container, and then the smaller pieces of data are actually also bigger. First name, last name, right? Now take note, the first name, for example, is Daniel, right? Which in itself is another container, which is having smaller pieces of data, right? So, do you remember that movie, Inception, where it kind of like go deeper and deeper into every dream, right? So this is kind of the same thing. Bigger container, you go and select one container as a smaller piece of data, right? And inside that smaller piece of data, you'll realize that it's already, right, another another type of container, and within it are smaller pieces of data, right? And you can keep on doing this um, as deep as you want, right? But ideally, there's a limit to this because the amount of time and resources that a device will use will increase the deeper those nests go. Okay, so ideally they like to stick to three nests. If you can, if you go over that, try to think about your way or your approach to the problem and see if there's a different way. Because again, the deeper you go, the harder it is to retrieve those data. The more resources it will take. Okay, but point is there are some data sets out there that could go very deep. Um, mm, but even so, with the advances of technology, right? Our processors are now so fast, our RAMs are big that we can cater to those big data structures, right? Um, okay, so let's get back to this one. The main point here is that we can access those smaller pieces of data, right? Now, how do we access that one? We access that one using a subscript operator, okay? So take note the name is subscript operator. It's not substring, subcharacter, subheader. It's a subscript operator. This is because this can be used in other data structures, right? So you're going to be seeing this format all over the place in almost any library, everything as long as Python is involved. All right, but here we're just focusing on strings, right, so that we can understand it fully. Okay, now name Alan Turing, right? If you say name of 0, it's gonna access the very first one, letter A, so that's why it displays A. 3, it's N. Okay, if you get the len of name. So take note. Remember when I said that you can put operations or functions inside other uh, arguments in place of arguments um, as values, right? So in here, right? So our subject operator is an open and close bracket, and an integer expression, right? It says expression, but it can just be just one number, right? Len, if you remember, returns what? It just returns one number, right? But in this case, if you say len of name, it will return an index error because it goes out of range. It goes out of range. Um, so you have to do a len of name of the variable itself minus 1 to get the last character, which is G, right? You can even do negative values. You can do start counting backwards. That's why it's displaying G and N here. Right, so just quick an example here. So using the name itself, right? Okay, so assuming that name is miscellaneous, right? So what we do if we say name of 0, we get the letter here. What's this? Oh, okay. It's pending execution. Stop this one. Alright. So as you can see, we are accessing the letter T or the very first character, right? If we want to access the last character, it's just -1. Okay, so essentially you're counting from here, right? -1 goes to the end. So you start counting from the right to the left if it's a negative number, right? Or you can use the what? Len of name, right? So what will the len give us? It will give us the number of characters. How many characters are there? 1, 2, 3, 4, 5, 6, right? But the number starts at 0, not at 1. So that means if we want to access the last letter, it has to be 5, right? So we need to do -1 here. And that's why it has the same output as before L, right? You might be asking why is it starting at 0? So, all right. So why is it starting at 0? Um, that's just because that's how data structures work, right? It will always start at 0. It's I know there's a deeper reason for this, but ever since before, it's been that way whenever you're dealing with data structures. It always has to start with 0. So that's one thing that you have to just get used to it and just accept that one. Let's see. These numbers have a specific name, right? We call these the index numbers, right? Because just like with indexes, right? Index cards, you know those folders that um, you keep, right? And then there are some letters that pop out uh, at the top so that you will know at what part you're looking for. Like these are the letter X, these are the letter G's, right? In the same way, that's how these indexes work, right? They tell you where, right, a specific character is. So I'm looking for R. Oh, okay, that is on index 6, right? Something like that. All right, so these index numbers essentially tell the location of a certain character in that string, or in, in other words, the location of a piece of data inside of your data structure, right? All right. Um, let's see some more examples here. So here, it's just a very simple for loop, right? Nothing too complex here. We just wanted to display, right, the string accompanied by its index number, right? So as you can see here, we are printing out index and then data index. So basically, we're accessing the data and then using index here variable to be the subscript operator, right? So nothing too complex about that. It's um, let's see here. So you have like what was that again? You have a for loop, right? And then you create a variable that holds uh, uh, data from a smaller piece of data from a data structure, right? Uh, for x in, right? But remember the function that we use the range, right? We use the range to give out numbers, right? To give out numbers. So if we say for x in range, right, of how many characters there are 6, right? 6. So it will what? What are the numbers that it will give out? It will give out numbers 0 to 5, right? Because 6 is not included. This is how the range function works, right? So I want you to give out 6 numbers, but not including 6, starting at 0, because that is the default, if you remember. So range, right, for x in range 6. Um, so if we print out x, what will happen? This will just be 0 to 5, right? So now we have these numbers, right? So what can we do with these numbers? Well, we can pass those numbers and access and use them as subscript operator on the name here. So we can then just say name, right, of x. Okay, I hope this makes sense because x here, remember, changes every time we iterate, we repeat the loop. So, meaning every time the value for x here changes because it gets a new value every time it iterates. So if I were to do this one, it will access a different character every loop, right? It goes from left to right because x keeps on changing on every loop. Okay, so I hope there's no question in this part, right? We discussed in detail how range works, how for loop works. So yeah, I hope there's no question in this section. The main point here is this one, right? So instead of us uh, accessing the smaller pieces of data in this string one by one, like you know, instead of doing like 0 and then name of 1, right? Sorry, name name of 2. Oh, okay, I can do that one. 3, 4, and then the last one is 1. Okay, so instead of actually doing this, right, we can see that there's a trend, right? From 0 to 5, we can see that It's a sequence of numbers that is spaced equally. So 0, 1, 2, 3, and we know for a fact that a range function can do this, right? So that's why we use range here, because it will give out these numbers in the same way. So instead of writing them like this, we can just write a simple for loop and it will give us the same output still. Okay, this is the entire logic. We just replace all of this into just one line like this. Alright? Okay. Let's see what else can we see here. It's using len of data. Alright, so that's what I didn't do. Why is it using len of data? So this, right, what's the difference between using range 6 versus using um, range. Actually, let's print this one out. I want to show this one to you guys. Okay. Range of name. Len of name. And then since this is a len, 6, yeah, there's no need for a minus 1. Alright. So if we print this out, right? Let's add a separator here. Right, sorry. Let's add a separator. Alright. So Daniel, right? Same output, same everything. The difference comes. Alright, who can tell me what is the advantage of the bottom code versus the top code? Okay, the only difference is one is using 6, the other one is using len of name. Who can tell me what's the advantage of the lower code?
The lower one would be more flexible if
Alright, so why is
the
it more
name
flexible?
changes. Um, the range is not defined,
The range is
while the
not
first
defined,
one
right?
it's like 6 already.
Okay, correct. So that's exactly correct. So the lower code is flexible. It's not fixed, right? What does that mean? That means we can change the name anytime that we want, and it will still display all the letters, right? So if I were to change this one, instead of Daniel, I were to ask input here, enter name. Now I can enter any name that I want, and then it will still print out correctly. So if I were to say like a bunch of characters like this one, all right. So as you can see, it returned an error at the beginning. Why? Because oh no, there's no error. It's actually still correct. I thought it was this one. Um, since range is just 6, it will just print out the first 6 letters. But this code here is very flexible. It can handle any kind of input. It can show you all the letters and its equivalent uh, index number, right? Okay. So yeah, right now we're calling them index numbers, right? But uh, technically, right, the way that we are accessing them, if you really focus on how it works, right? Like on number 10, it's J. On number 11, it's A. Number 12, it's S, right? So what kind of format does that look like to you? It looks like what? It kind of looks like a variable, right? It looks very, very similar to variable and its value, right? At 1, it's S. At 2, it's D. At 3, it's F, right? So it's very similar to that, right? But we just change the name into um, index numbers. Why? Because it's using numbers, right? Later on, we can actually make one ourselves, and at that time they would be called index numbers, but they function the same way. All right. So understanding this concept will make a lot uh, make, make things a lot easier down the line. All right. Okay. So that's it for the subscript. Slicing for substrings. All right. So this is um, a way to select certain sections of a string. Okay. So we're gonna use the colon operator. Basically, you're just saying that um, starting from here and ending at this number, at this index number, but not including that number. So 0 to 1 in my file.text, so 0, 1 is y, right? But not including y, so we'll display m. That's why we see m here, right? It's that simple. This is called slicing, right? We are slicing to a substrate. At this point, this is called a substring, right? So this is very specific to um, this is like more like an operation at this point, right? When Python sees that colon and then two index numbers, it sees that as an operation, right? And then um, whatever is left, right? It will get that one, and then that will be the new substring. So that's why it's named substring. Right. Let's see. If the left part is left blank, it will automatically start at the beginning. If the right part is left blank, then it will automatically um, default to the end, like go directly to the end. You can also use negative numbers like this one, okay, um, to count backwards like this one, so negative 3. So take note, it's negative 3. You're just indicating the starting point, but the way that the operation works is that it will still count from left to right. Okay, so take note, negative 3. So uh, negative 1, negative 2, negative 3, right? So start here, but after the colon is what? It's a blank. So it means go to the end. So start at negative 3 and then go to the end. That's why we have txt here, right? It's not it's not gonna go to the left. It's not reading in reverse. It's still reading from left to right. You're just indicating the starting point at negative 3. Okay. Now sometimes it's a lot easier to use the negative, especially if the string is very long. Um, but sometimes it's a matter of convenience, like whatever works for you. Okay, so why do we find this one useful? Let's say, for example, you're scanning like files and then you want to isolate only things like text files or specific formats like PNGs, GIFs, right? You can do that, right? You can make a program in Python that will separate only the things that you want, right? Like this one. Um, let's say you have a list. Again, this is a list. Whenever you see two brackets and it is assigned to a variable like this one, that is what you call a list. And then each smaller pieces of data is separated by a comma. Again, this is a data structure. A list is also a data structure. One big container and then smaller pieces of data. It just so happens that the smaller pieces of data are strings themselves, which again, you can access them and treat them as containers themselves and then access the characters when they want, right? Okay, so I hope I'm making sense. So what are we doing here? Basically, we're trying to isolate which which of the strings in our list have the txt in the file name, right? So this is a very specific process. Uh, if structure in Python. So if the txt in file name. So we're basically asking if this specific substring exists in um, this string, right? So In the first loop, it's asking for myfile.text. So is the dot text inside myfile.text? So if that is true, it will print it out. That's what we see here, myfile.text. If dot text in my program.exe, which is false, so that's why we don't see it in the output here, right? Um, and then on the last part, it's true because .txt is a substring of your file.txt, right? So this is one way of doing that, but you have to have a list of all the files basically on that folder, right? In this example, it's just 3 files, right? But yeah, let's see, data encryption. Right. So these are one of those things that I said earlier. Um, that I'm gonna leave it up to you guys to study on your own, right? Read it when you have time or if you're interested, right? So we're not gonna go too deep on this one. We're just gonna breeze through this. These are just examples of um, programs in Python, right? So we have data encryption. Um, let's see. So where, all right. In a way, this is related to data structure. Why? Because we're using keys, right, to encrypt the messages. And from that, um, we can kind of like manipulate how the data is presented by accessing each one and changing the value of each one. So this is the way that this one works. So let's say that the Caesar cipher is a very old um, data encryption technique. So let's say that the message that you're trying to deliver is invaders, but this will be encrypted as something like this, right? Um, so before, like, um, what they would do is only the receiver knows the key, right? Only they can decrypt, supposed to be, right? That's the plan. Your this one, right? So this is encrypted to this, and then the other side, the receiver has the key, right? Or something like it. It it varies depending on what they are using as a key, right? It can be um, I don't know the exact name for that one, but a kind of board, right? That has all the letters jumbled up, and then all you have to do is like count how many letters, and then whatever letter that is, that number ended up on, it has an equivalent letter somewhere else, or something like that. Um, but anyway, they needed that key um, to decrypt the message. So they what aside from the key, if you wanted to intercept the information, you needed what? You needed the key and you needed the message, right? If you have the key but not the message, then it's useless. If you have the message but you don't have the key, it's also useless. You don't know what it means, right? You need to have both in order for you to understand what the message was sent, right? Um, so we're gonna do the same thing. This is gonna be the same thing, but we're gonna be using Python to replicate that one, right? But in this case, right, how are we gonna do that? Okay, we're gonna do that one because we're gonna do that one by um, let's see, our key here is +3. That is our key. So whatever letter, we'll add 3 to it, and then that will be our new letter. All right. So let's see. Invaders, right? A, it becomes D. So A moved 3 letters. So +3 is the key, right? A, 1, 2, 3. It becomes D. All right. Now A, it just so happens, has an equivalent ASCII value of 97. D has a number of 100. Now why do these numbers matter? Okay, because this is how the information is sent over the internet, right? It's actually sent in um, ASCII, right? The letters that we sent are has an equivalent number based on the ASCII code, right? So we're actually using a very big database of what we call, let's see, how about that? I think it was called Unicode. Yeah, there you go, Unicode. So Unicode has um, the goal of Unicode is to have every character in every language in the world has an equivalent representation, has an equivalent code, Unicode, right? That can be represented, whether they will be a number or a combination of letters and numbers. But the main point here is that um, so Unicode is all of the language in the world, right, has an equivalent code. ASCII is a subset of Unicode specific to the English language, right? And you can search that one over the internet, like ASCII code. Here's a table ASCII. All right. Now before ASCII was enough because mostly everyone used ASCII, but uh, it became difficult when different languages started to, use the internet, and that's why they had to find a way to represent each character, each symbol in every language with their associated ASCII number or character. So as you can see, we have the equivalents here. We have the decimal, octal, hex, bin, binary, the symbol itself, the HTML, right? So these are all the equivalents. Let's look for the letters. The capital is separate from the small caps, so as you can see. Letter A has a decimal value of 97, so we're using decimal value, right? And up to letter Z, it's 128. So these are how these letters are represented when we send information to the internet, all right? So where are we? This one. Right. So why does this matter? Okay, and why is our key plus three? Because you can't actually add three to letter A, right? It doesn't make sense. A plus three makes sense, but 97 plus three makes much more sense, right? So what do? The concept is actually very simple. You take the letter, convert it to ASCII, add three to it, and convert it back to um, plain text. That is your encrypted letter. Okay, the same thing works in reverse. You get the encrypted letter, get the equivalent ASCII minus 3, and then convert it back to plain text. That is your decrypted letter. All right, encryption, decryption, right? It's just the opposite, and that's basically how the Caesar cipher works using Python, right? You're using your plus 3 here is the key. This is your main um, secret, right? But these days, this is not enough for security, right? You know, our computers are very fast nowadays that they can crack a Caesar cipher very quickly. So it's not really safe anymore in this day and age. All right, here is a code for how to do that. So I'll leave it up to you guys to explore that one further, right? So it might look simple, but from what I explained earlier, that's how it works, right? Convert the letter to ASCII, add the key, add the key value, right? So the plus 3, and then convert it back to letter. That is your decrypted or encrypted letter, right? So this is the decrypt. As you can see, there's a minus here. On the encrypt, it's just add, right? Add. Um, the logic here is that there's an extra bit of logic here that might seem confusing. but it makes sense. Um, because what would happen, right, if your character is Z and then you were to add 3, what would be the character? It's this one, right? So it doesn't make sense. Um, in this code here, I think it's this part where um, when it reaches a certain point, like 122. So when you say 122 plus 3, instead of going to 125, it will go back to letter A. So 122, 97, 98, 99. Alright? So there's a certain logic of that around, I think it's this part for the encrypt, and then this part for the decrypt. So I'll leave it up to you guys to find it out. But the concept is the same. Um, it will just loop over back to letter A. All right, let's go to the next one. Here's an example. So in graders, the distance value is 3, or this is the key. This is the encrypted one. This is an example output of the decrypt code. You input this, you input the key, and you get back the original message. Yeah, this is what I said earlier as well. Block cipher is one of the recommended methods these days. If you take a look on your phone, right, and then you were to create like a hotspot or even a Wi-Fi, right? You'll see there AES. If you see that one, AES, so that's short for um, Advanced Encryption Standard. So that's the one that we're using right now. From what I know, it's a lot harder to actually crack, but you know, um, there are still some ways to actually go around that one, right? But usually brute force is not the way to go. Um, that's why malicious hackers use other methods like phishing or malicious emails, right? Or uh, other ways to get information out of you so that they can access the data, right? Um, for example, phishing, right? Um, they get your what security records, your security question and whatnot, and then from that, they can reset the password themselves, right? What else? Trojans. So Trojans are malicious code hidden in programs or emails, right? So the moment that you click a link or you open the website, you have already downloaded the Trojan, so that's dangerous. Most email services nowadays have a way to detect that one, but nothing beats common sense. So if you see an email that you don't recognize, it's better to flag it as um, spam or something that's you did not expect to receive. So delete it or put it in a spam, and then just to be safe. Uh, Sometimes they are using like how do I say this, like very simple deception, like for example a bank. Let's think of a bank thing. Uh, let's see. All right, let's say for example BPI, right? I think there's yeah, okay. So who here can tell the difference between these two characters, right? So it might look, if you just read it directly, they might look the same, right? Letter I, but the other one is actually a pipe, or the one that's above your enter key. Um, so it might look the same, but some sites use something like that, okay, to trick users into thinking that they are accessing the correct site, and then they what do they do? They log in with their credentials, um, and then they're your credentials are stolen. So you have to be careful with that. You have to always check the address at the top. Make sure that it's correct. All right. So that's really the encryption. If you're into that, maybe you can go to um, I think we have a course for that one, yeah, or uh, the one focused more on security purposes, right? Um, yeah. If you're into that, you can ask the admin. I think we had a course for that one, so I'm not specialized for that, but um, they still use Python, but they expand furthermore into other languages as well. Okay, so strings and the number systems. All right. Uh, do we actually need this one? Actually, no. Unless, of course, that's what you're dealing with in your data science project. But um, basically, we're just converting from one system to another. Okay, so basically, um, let's see, from binary to decimal to octal, right? And you also have X. Um, there are some. I think there's some code here that will show you how, right? Yeah, in Python, how to do that in Python. So you can just copy this one and explore the code on your own. I'll have to go back to this one. All right. But again, this isn't really that needed in data science because we have functions that will work automatically for us with this. Okay, but let's explore this one a bit. Um, so the reason why, right, you might be asking, why do we have other number systems? Right? Like, why do we need that one? It's because of uh, saving more information into lesser number of characters, right? Um, let's see. You ever had those errors in Windows where like it's a very long address, a memory address, and then um, it will just explain like there was an error in 0x number and then letter. So actually that one is a short representation of a much longer memory address, right? So an address in your memory where that data is located, where that error occurred because that data is not there, or it was corrupted, or uh, they did not find it, something like that. So it's a way to represent large pieces of data in a smaller package, to be exact. All right, but it's not at this point in time. You might see that um, the decimal is actually smaller, right? So you see 415. There's just three characters, but in the octal notation, it's 4 characters. So it's actually more, right? But the bigger the number goes, the more these number systems shine because they can represent bigger numbers and fewer characters. Okay, so that's the idea behind it. Let's see. Arithmetic or a decimal, yes. So the 10 number system, the base 10, we call it base 10. So those are the numbers, what? 0 to 9. It's not 1 to 10, it's 0 to 9. Um, you know, just just a review. Binary is 0, 1. Others, base 8, so it's 0 to 8. And then hexadecimal is 0 to F. So after 10, you start with letter A, B, C, D, E, F. Yeah. That's what you get, right? So, all right. Let's see. How do they work? So here is an example, right? So remember those lessons in mathematics we had where we discovered the ones position, the tens position, the hundreds position, right? So there was actually a reason for that, and it's because of the positional value of those numbers, right? So 415 of base 10 actually means what? Um, 5 times 10 to the power of 0, 1 times 10 to the power of 1, 4 times 10 to the power of 2. Now these positions are what? These positions are similar to what we have earlier, right? Like index values. So we start at 0, okay, based on their position. Now, as you expand this one, you'll see that it's actually just 4 times 100, 1 times 10, 5 times 1. So it's actually 450 is just 400 plus 10 plus 5, right? You can get all the number combinations using this method, right? Um, so this is the first three positional values in the base 10 number system, okay? So of course, after this is the thousands, after the thousands is the millions, right? So on and so forth. The same thing goes for binary, right? So what is binary? So it's a base 2. You start with the base number, base 2. Earlier we started with base 10, right? So that's why we see 10 here. So base 2 is binary, so you see 2, and then the position itself. So 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, and so on and so forth, right? The only difference with binary is that we start, it's just multiplied by ones and zeros, okay? So ultimately, after you add all of them up, you will get the number 103. This is how um, this is the equivalent binary. uh, this is the equivalent of the binary number. It's the decimal equivalent, right? So it's 1, 2, 4, 8, 16, so it's 32 and 64. 64, 32, right? You add that one, then you add the 4, the 2, and the 1, right? So, if you keep on looking at binary numbers, you start to memorize the sequence, right? And in fact, 1, 2, 4, 8, 16 is not really that uncommon because you also see this one in what? In others and other specs like uh, processors, right? You see 32-bit, 64-bit, right? So it's the same thing. So in the future, you might see something like 1 to 8-bit. If you're into graphics cards, then you'll also see those kinds of indicators like uh, forgot the 1 to 8-bit memory. I forgot what it's called, but there are specifications that look like this. So 64-bit, 32-bit, in the same sequence as this one. Okay. Let's see. Converting binary to decimal. So this is one way of doing it, but there's an easier way in the end for us to do. Um, let's see. Decimal to binary after each division. Oh, it's just a process. Right, you can try this one out if you want. Basically, it's what it's doing. It's making use of the modulo operator. All right, and this is a format string here. Decimal remainder of its string. Okay, well, decimal is greater than zero. So basically, we just keep on dividing by 2 and get the remainder, whatever the remainder is. And then the decimal will be the floor division of that. So you separated the remainder and then the decimal. And then you keep on repeating this pattern. Um, you will eventually get the binary equivalent. But again, this is kind of like a sneak peek of how the functions that we will learn work underneath. Alright? So you can try and explore this one. But here's a um, way, right? A visual way that we can let's see that one. So enter a decimal integer. So we start at 34, right? So what do? You keep on dividing by 2, separate the integer and the remainder. So 34 divided by 2 is 17, right? So um, you have 17 here at the beginning. Next is what? Let's see. 0 and 0. Why is there 0, 0 there at the beginning? It's because else while let's put let's see, where did the 0 and 0 come from? It came from the first remainder and bit string. Ah, okay, right. So this is the output. Um, 34 divided by 2 is 17, right? What's the remainder? The remainder is 0, so that's what we see here. And then we take that 0 and push it to the right. So this is what we have here. This is the final output. All right, 17 divided by 2, we got what? 8, and the remainder 1, right? 8 plus 8, 16, plus 1, 17. So remainder 1, integer 8, and we push that 1 to the right. So now 0 will have 1, right? Stick on its left. Okay, we do the process again. 8 divided by 2, 4, and it has the remainder 0. You push the 0 to the right. This is now our bit string, 0, 1, 0. Divide 2, 2, 0, push the 0 to the right. Again, 2 divided 2 is 1, 0, push the 0 to the right. 1 divided by 0, 1 divided by 2, remainder is 1. We push the 1 to the right. And this is our final representation, right? And if we count this one backwards, it's the same thing. So 1, 2, 4, 8, 16, 32. So the numbers with ones is 32 and 2, which is 34, all right? So yeah, just explore this code if you have time, see how it works. But basically, it's just making use of the modulo operator. The modulo operator is a division, but gets the remainder instead of the quotient. Okay, this is the floor division, um, which gets the integer part of the quotient and not including the um, decimal part. All right. Okay, this is just a table for a quick reference. Okay, so that's why. So this table is more like a quick reference to convert decimal to octal to binary. So it takes one number and then gets the equivalent binary in groups of three. So that's what it's trying to do. If all three numbers are 1, you get 7, right? Which is the maximum number because it starts from 0 to 7. That's octal. Okay. Hexadecimal works the same way, but it groups the bits into 4. Right? 4 because what's the maximum number? 1, 2, 4, and 8. 8 plus 4 is 12. 1, 2, 4, and 8. 8 is 12. 12 plus 2 is 14. Plus 1 is 15. 15. So 15 is F. Okay. But if we're starting from index 0 to 15, yeah, okay, I think that makes sense. So 4 numbers, 1111 will be equal to F. Alright. The same process as how octal to binary works, right? So from here on, you can kind of see like binary is the middleman, right? So from binary, you can convert it back to whatever the equivalent that you want, right? So if you want to convert this one to octal, you have to group them into 3. Let's see. Methods, string methods. Okay. All right. So I remember the rand int earlier. So I didn't actually discuss that one in detail because I waited for this part. String methods. So this is the part where methods are, we can see a lot of methods, not just one. So if I were to discuss rand int earlier, it maybe maybe it would be confusing, right? So at this point, this is the correct time to discuss what methods are. Okay. Let's see. Let's have a quick break. Actually, it's 3:32. Let's have a quick 15-minute break. Let's be back here by around 3:45. Around that time. Okay, not exactly 3:45. Around that time. Okay. So let's have a quick rest, absorb the information that we just learned, and get some coffee. Right. See you guys in a bit. Have a good one. hope everyone is back and had a good break. Alright, can I have some thumbs up to know that you guys are here? Okay. Alright, Nick is here. Patricia, alright. Alright, let's continue. So, what are methods, right? Okay. So, remember earlier when I said that um, the string, right, is a data structure. Okay, so there are um, smaller pieces of data inside of it. Right now, you can treat methods as some of those data. Yeah, but um, the way to access them is different because if you want to explain what methods are, they are functions that specifically act on that specific uh, data structure it's related to. Okay, so let's have this one for example: sentence dot split. All right. Now here the data structure is okay. Let's say we have right, our data structure is a string. So we say name dot uh, was the split, right? So it needs to have more than one word, or maybe another name. Uh, maybe another person is Zach. Okay, so name dot split, right? If I were to run this will appear like this, right? Now the way that this works is that name here is the data structure. Dot here, the dot is the way to access method, and the method split, right? But specifically, this is called the dot method, right? This dot method is used pretty much the same in every other language, um, like any language, right? So odds are they also use the same way uh, of accessing methods, right? But it's not just methods that it can access. It allows us to access properties and methods, right? Now we're still at the part where we are describing methods. So methods are functions that act on the specific data it is attached to. Okay, or you can also say that functions that act on the object, right? So we're getting closer and closer to um, what the definition of an object is, right? In terms of programming. So methods, right? Functions that act on the specific data. Dot method allows us to access properties and methods, right? So what does this mean? This means that um, there can be more than one methods, right? So let's dissect this one further. So we have name, right? The name, what is our data structure? Our data structure is a string, meaning in all other strings, whatever string they are, the split here, the split method exists, okay, for any kind of string, right? Um, as long as the data structure is a string, one of those methods available is the split. All right, that's the concept that I want you to put in your mind, right? The data structure of a string. Okay, now the the split here, as you can see, will only act on name, right? If I have another split here, let's say um, company, right? And then this is micro micro Linux, right? Like the combination of Microsoft and Linux. Um, and then I were to say company dot split. I can do this. Why? Because company, right, is the data inside of the variable company is a string. So technically, I'm accessing the data structure of a string, and then I'm using the split method, right? But technically, the method and strings they are just the same. It's just that methods are locked onto the subject or the data structure that they are locked into. All right. Okay. So in this case, the split here only acts to company. The split here only acts on name. All right. It doesn't. The split here cannot act on whatever name is, right? Because this one belongs to this specific data, right? It just so happens that they have the same data structure. That's why they have the same methods. Okay, so I hope I'm making sense here. So if I were to run this one again, I can see that only the last output or command here is displayed. So micro and lino, right? So they have different outputs. Now, let's see. I think it's better if I were just to print this one. See the output for both. All right. Okay. So on that note, right, we say that the dot method allows us to access methods with an S plural. So that means there are other methods available, right? So what are what is the data structure that we are concerned with? We are concerned with the string data structure, right? And what are we looking for? We're looking for the methods available for the string data structure, or yeah, the string data structure, string methods, right? Okay, so don't confuse data structure with data type, right? There's a small difference, right? All right, so these are all the Python string methods that we have, okay? And if you look at on the left here, there are other methods available for what? List, dictionary, tuple, set, file, right? So on and so forth, but the concept is the same, right? So what are the other things? We have caseful, we have find, we have um, there's an uppercase, I think. Upper, right? So if you use upper, it will convert the text to uppercase, right? So it can be as easy as print company dot upper, all right? Like this one. Sorry. Okay, like that one. Okay. So, right. Um, like I said before, this specific method only works on the string data structure, but for this specific upper, it only works for this specific data that it is attached to, right? It will have different output if it's used on a different data. So if you use it on name, it will have a different output. So I hope I'm making sense. Um, what else? All right. So it just goes to show that if we encounter other data structures, they will also have their own methods and properties, right? So if you want to access them, you can just use the dot method, all right? And like what we did with functions in the beginning, right? Functions, there are what? Parameters, right? We also give it arguments. It's also the same for methods. There are some methods require arguments. Some methods, um, yeah, require arguments. You can do the same thing as you do with functions. You can pass expressions as arguments. You can pass functions inside of um, methods as an argument. Okay, so we're kind of mixing things up here, right? So as long as you don't get lost as to what what data you are currently um, working on, right? As long as you are not lost, you can mix different um, methods of different data types in a single line, right? So what do I mean by that? Let's say len, right? Len is what? What is len? Len will give out a number. Hmm, let's see. All right. Let's say just to prove a point, like I want to mix and match different methods. Oh wait, before that, we need to explore methods of other data structures, which we haven't actually discussed yet. All right, we'll get to that. Ah, okay, I think I know. So yeah, um, this is a string, right? So a string, Michael, Lino, what else? Let's use this one. Okay, DOS, iOS, Android. Okay, so there are five, right? If I were to split them up, um, I will save that into a variable, um, company that's split. Or since this will give me a list, right? Where did we use a list before? We used it on a for loop, right? Okay, so instead of putting the split there, if we put this one in a for loop, right? For x in company, right? Company that's split. Yeah, company that's split. I want to access each word. I don't want to access the whole string. I want to access each word. So this is what I will do. So if I want to print out x here, this is what will happen. Okay. Now at this point, what am I doing? I'm accessing x here as a string. So that means anytime here I can use what? Um, string methods as well, right? This is from a list. Now I am accessing um, string data. So string, the data string has string methods available. So I can do upper here on each one and then convert each output into its equivalent uppercase. See? All right. What else can we do? What if we were to convert use numbers instead? All right. So this doesn't work, right? Upper doesn't work. Okay. So if I were to be to 4, this is still a string, right? Remember, this is still a string. This is not a number yet, but I can say pass a float here, right? So now this is a number, and then from that point on, I can do any mathematical operation because now it is a number data type, right? So now that's the kind of output. Okay, so always remember what type of data you're dealing with. Okay, if it's a data structure, that means it has properties and methods available. If it's just the what I say is the lowest level of data, right? Then um, or the raw data itself, that is the point where nothing is lower than that, then um, we can say that if we are at the lowest level, let's see, you can't actually um, access anything anymore because that's the raw data itself, right? That's the lowest level that we can go. So one of those examples is values like true or false or actual numbers, right? The numbers itself don't have something smaller than that one inside of it. That's the smallest um, as small as the data we can get with it. So those are the raw values themselves. But if there are data structures like strings, you can subdivide them further. Okay. Now, with that said, okay, what are we trying to do at this point? So, um, it's doing the same thing as I did, but let's see. It's using the split here to separate the entire string into a list, and then list of words. Alright, it's counting how many words there are. So take a look at what len is doing here. So what we use list of words is sentence that split is what it will give out a list of the words. So when you use len on that one, it will count how many words there are, not how many letters, right? After that, it's just a basic for the word. It's counting how many letters there are for every word, and then um, getting that sum divided by how many words there are. That is your average word length, right? But the main point here is the split method because this is the one that we use to divide the string into uh, each word, right? Each word is separated to its own string. Okay. Um, so this is what we discussed earlier. This is what we call the dot method. Um, let's see. So here, there's a specific line in Python. All data values are objects, right? So this is the point where we can discuss what objects are. So we have specific functions dir and help here to help you out whenever you are um, lost. But specifically, I like the dir. Let's try this one. Okay. So the dir or the directory will give you a list of all the properties and all the methods that is available for a single piece of data or a data structure. So if I were to say, right, we keep on discussing string, right? So if I were to say dir of any string, any kind of string, right? There, that one, or it can be a variable, and then from that variable, it's a string. It's the same thing, right? So if I were to say dir, right, what do we see? We see a list of properties and uh, methods. Now, how do you know which one is a property, which one is a method? The ones with an underscore is a property. The one uh, without underscores are the methods. So, as proof, right? If you go down here, let's see. You should be able to find len here, and also upper. Is len here, len, 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 or maybe len is a property. Here, okay, len is a property. So meaning, when you were using len as a function, it's not technically counting how many characters there are. It's just accessing this property, right? And it's giving you that property. So let's access that one. How about we? What happened? How about we print that one? Okay. Let's say print. Mm, let's make this one simpler. It's too long. Okay. Let's make this into a variable. Make it easier to reference. All right. So name dot underscore underscore len underscore underscore. So this is a method wrapper of string object at. Alright, so it's a property, but we have to access it like it was a method. So you put in open and close parentheses. Alright, 6. Now, if I were to use len on Daniel, what was the output again? It's 6, right? So DANIL, that's 6 characters. And inside of this property is also a 6, right? So what does that mean, right? So it will all make sense. So what does that mean? Basically, um, the properties, right, as well as the methods, actually, is describing, right, the data. Where will they go down? Is describing the data, the string Daniel, right? It's describing what it is. So properties, right? Like aside from the len, there has to be other. Let's see here. Mm, what other properties can be used that we can sort of understand what it's used for, other than len? I can't scroll down. Size of. Okay, this is good. Size of. What is size of? Size of, I think, is how much memory is that piece of data consuming. All right. Size of. All right. So it's 47. I guess this is in bytes. So that specific string consumes 47 bytes of space. Okay. Um, let's see what else can we find. Init, reduce, new, set attribute. Oh, string. Alright, let's see. String. What is the string itself? I think string itself is the characters, these ones, right? Get state. Alright, so I don't know what the other properties are, but we don't actually need to know what they are. What is important is that both the properties and the methods, as well as the smaller pieces of data inside of that specific data structure, all describe one thing. It describes this string, okay, that specific string. Meaning every other string out there also has these properties, right? These methods, right? Um, one methodology that I can think of is, um, let's see, uh, all right. So if if you were to describe, let's go back to the car. If you were to describe a car, right, you would describe it as what? Um, it is made out of metal. It has the color blue. It has 4 wheels. It has glass tinted. It has 4 seats. What about the methods? It can. It's an automatic. It has air conditioning. What it can do, right? It has retractable roof. Mm, what else? It has an alarm system, right? So those are the things that the car can do, right? Everything that I've said is describing what that car is, right? Now the same thing, right? The properties and the methods that describe the car The same thing applies in programming. The properties and methods is describing the string Daniel, right? Now, if we were to expand this concept, right, that is how we arrive to objects, right? So, in the very beginning, I told you guys that treat everything in Python as objects, right? Because it absolutely makes sense in the end. Because all the data that we have here, right, if you use a dir on them, they will have properties and methods, and then you can see their way that they describe that piece of data, right? So we don't actually know what those pieces of data are used for, but we know that it is describing that piece of data so that it will, it will function correctly. So that's what objects are, right? It's the complete description of um, that data, right? We can access it, right, using the dot method for the properties book and the methods. And if it's that data is a data structure, right, then it will have smaller pieces of data. Each possibly could be an object with their own properties and methods, right? So yeah, I hope that wasn't confusing. But the point here is that you need to understand what objects are so that you won't get lost when you're reading definitions. Um, when the time comes when you learn uh, using other libraries, right? Because that word gets thrown a lot, right? And if you're like me at the very beginning, I was very confused what objects are, what data types and data structures are, like how do you know what is an object, right? So uh, it was very confusing even with the definition given to me before, um, both in textbook and from Google. So it's very, very hard to encapsulate that idea that it's just a description of what you're dealing with, what type of data you're dealing with, right? Whether they are holding more pieces of data inside or not, right? Whether they have um, more properties than other data types or not. Okay, now a level above objects is what we call a class. All right, so we'll get to class soon, but that's the highest level that we can get. All right, so let's discuss further this one. String methods split. All right. Let's see. Okay, so this is here. Take a look. It's combining different things. So file name that's split, right? So file name that's split, and from that point on, where do you remember this one? Braces and then negative one. This is what we call the what subscript operator, right? And when do we use this one? You are trying to use this one when um, the data that you are dealing with um, has index numbers, right? And then you can access them using index numbers. So right now, since we're using split, this will become a list. And if you're dealing with list, you can just think of it as similar to strings. You can access them, the pieces of data inside of it, using subscript operator. This is what we have here. Text files. This is we don't actually need this one. Um, Opening files now. I don't see this one a lot in data science, like opening files and then like uh, using the open and write method in Python. I mean, do we open files using Python in data science? Yes, but we are actually using something else. All right, this is the one that goes with Python by default. So you have an open, right, and a close. Um, but it's very limited, right? We're gonna be using something else that can open even more files, right? It can open PDFs, it can open Excel files, it can open Word, it can open any file that you want as long as you have that specific function that goes for opening that um, file format, right? But the sequence of um, how they do it is pretty much the same, right? Um, if you try to look at what's happening here, you open, you write, you close. It's mimicking what we are actually doing with files themselves, right? We open the file, we write something. After we're done, we close it, right? It's mimicking that exact behavior. Now, you have to do that one also whenever you're trying to open and save data using Python, right? Now, you might not be using these methods and functions exactly, but um, the point is they follow the same flow. You open, you write something, and then you close. There are some specific functions out there that do this automatically, but I want you guys to remember that what we are trying to do is always to mimic real life, right? With, but programs just do it faster than us. Okay, so if you're in a competition, right, and then the computer will just open 1,000 files a lot faster than us. Okay, so here, right, one thing to note here is that this is an open function, right? And after that, we're using the write and close method. Okay. Now the open, right, function will do something unique, right? So uh, in every function that we have used so far, right, we always say that it is returning a certain value, right? It's returning a number, it's returning a string, it's returning a list, right? So I want you to go above that. Instead, I want you to think of it as returning an object. Okay, so you are returning an object. What is the object? What is the object's um, data type? It's a string. So automatically you have access to string methods. Alright? Now, if we were to expand that one, right? Let's say we have a new data type. Alright, f open. The open function will return what? It will return to us a file object. See, file object. Data output can be output to a text file in file object. Now the open here, right, will open the file. It will return to this location a file object. All right. Now, what is this object, right? This can be considered as our new data type. Okay. So we are assigning the file object to the variable f. All right. Now, what do objects have? Objects have properties and methods. Automatically, if we were to access f, we can access file object methods. All right. So that's why after using the open function, assigning it to f, we go directly to f right, f close. Okay, that's the main point that I'm trying to get here. This this can be anything. This can be any kind of object. This can be a file object, right? What other objects are there? Like a 3D object or maybe a 2D object. Whatever object there is, right? You can classify that as a new data type, right? Because it part of that object, right, is describing what the data is. All right. So if your data is a string, then you will have access to what string methods and string properties. That's what I'm trying to teach you guys. Okay, because you're going to be dealing with more and more objects in the future, more and more data types. So if you don't have this one uh, understood carefully, you will get lost in the different data types that you're working on, because you're going to be mixing and matching these things, right? You don't just have the basic things like the number, the string, the true and false, the list, the dictionary. Those are the basic stuff. You can make your own data type, right? And this is where the understanding of what objects are really shine. Okay, now I said file objects, so automatically there might be file object methods, right? And as you can see here, it exists, right? So file methods. This is how you will search the documentation, right? So you have to understand, okay, what object am I dealing with? Okay, I'm dealing with this object, and it's a um, uh, okay, pandas. Let's say pandas. Okay, this is a pandas object. So meaning, since this is an object, right, it also has properties and methods. So you can um, look further into it, like what specific pandas object this is, and then it will say like, oh, this is concerned more on algebra, right? So you can go there and look for algebra methods, algebra strings, and so on and so forth, right? So now these are the file methods, and in here you can see the write and close. Okay, now take note, documentations are not always this good, this organized, right? The Python documentation that we saw last time was actually pretty good. It's very good. Um, there are other documentations out there that developers will just leave you questioning, like what is this used for? Um, how do we use this function? How do we use this method? So those kinds of libraries all end up with fewer users, right? And if a library has fewer users, then there might be fewer investors to it, so it will not be developed as much, right? Whereas those with good documentation, good coding practices, always having new features, right? They are the ones that are being invested a lot in. So, uh, yeah, try, if you're gonna use your own libraries, try and explore those bad libraries and then good libraries, and then see the difference in their documentation. Just be careful though. There are some, just like with anything on the internet, right? Anything that you download, always be careful what you're downloading, right? um, just to be on the safe side. Okay, so that's writing text. You can just skip this one. If you want, you can analyze this one further, but basically we're just opening a file, writing to it, and then closing it up. Again, we're not going to be using these functions exactly. Maybe we can, but there are better functions available out there in other libraries. Okay, so the open here can't actually, the open function can't actually open files like Excel. So yeah, yep, read line, strip. So right now, even though you are um, dealing with new code, right? You might be able to understand it now. Okay. Oh, this is a function, right? This is a variable. Oh, it's looping something. It's accessing that variable and using a specific method. All right. And inside that loop, there's another loop. What is it doing? I think it's converting the number into a word. Oh no, wait, into the word, the string into a number, and then getting the sum based on the name of the variable, and then printing out what the total sum is, right? So whenever you're stuck with new code, you won't be lost anymore, just by looking closely at how it's written, because all languages um, have similar structure, right? The syntax is the only thing that's different, right? But often it's not really an issue anymore. Once you learn one language, it's like learning everything else. Um, similar to real life, right? We all have the same rules. Like there's always a verb, there's always an adjective, there's always a subject. It's just that some languages have a different way of sequencing. Like if you know that in Japanese you have to like I think you have to put the subject at the last part of the sentence. I think so. In a way, um, that's what makes it different. But um, the subject is still there, right? The point is the subject, the adjectives, they're still there. They're still part of the sentence. So that's what I'm trying to say. Accessing and manipulating files and directories. Uh, this is not actually that relevant to us because our data set is just one file usually. Um, one file, yeah, it's just one file usually. You can get it from other sources and then you can pull it into one file, but usually you know it's just in one folder. I mean for me. So in case you wanted to learn how to navigate like the directory, okay, just like with navigating our file explorer, you start with where you are currently. So this is, for example, where we are currently. If you want to access myfile.txt, all you have to do is just um, call the file directly. Okay, so if you are already in your current directory, all you and the file is inside that directory, you can just call it directly. If you are in a folder inside of your current directory, right, you put the folder name in front with a forward slash. Okay, if it's a parent, all right, if the file is located a folder above where you are currently, so we call it a parent, you put two dots and a slash in the front. If you are looking for a file that's in the sibling, right, all you have to do is go to the parent first, then go to the sibling folder, then go to the file that you're looking for. Okay, so you can use this map if you want so that you won't get lost, but um, basically you're just um, instructing Python one by one where to go. So uh, if you want to access myfile.txt, right, so from current you have to go to parent first, then go to sibling folder, then file. If you want to access myfile.txt, so current, access the child folder and then the file. If you want to access the file directly and you're in the current directory, then just call the file directly. If you go to the file that's located in the parent directory, then you have to go up. Okay, call the parent double dot and the first slash and then the file name. Okay, so that's basically it. Alright, so import OS. We'll get to use this one more soon, but basically this is what we use when you want to um, import libraries, right? So a library is files, Python files with a bunch of functions inside of them, code inside of them that has a specific purpose, right? Like if it's pandas, then it's more focused on data manipulation, data formatting, and whatnot. Okay. In this case, it's using import OS or the operating system. We use this library if you want it to, um, if you want it to like interact with your operating system. So in this case, it's Windows. If you're working Windows, so you have the current directory path, right? So wherever you are running this one, right? So here in this case, just to show you how this works. So we are importing OS, and then we say temp is equals to os dot get we're at working directory, cd, right? And then print this one out. Okay, so as you can see, this is where this file is located, right? The notebook that I am using on, it is located where? Here, right? Now, where is here? It's in desktop, PC, this, and splash one. But the complete address is this, right? So as you can see, this exactly matches um, this one, right? So you can use this one to interact your um, with your operating system. I haven't tried this one in Linux or iOS, so I'm not really sure. But since this is Python, I guess they kind of anticipated that one, so I guess it might work. If you have some of those devices, let me know. Um, these are all the other functions that we can do with um, that is related to directories, right? So chdir is just a function that changes the working directory, get current working directory, list the dir or the different path names, make dir or make a folder, remove path. So it's just basically same as deleting a file. Rename is rename. Remove dir is removing a folder and all of its contents. Sep is just a variable really that holds a separator character. So again, I don't find this one uh, that much useful for us at this point, right? But it depends on you. If you want to create an output where you're separating the data into smaller pieces of subdata, then this will be useful for you. Okay. Um, so yeah, just know that this actually exists. Okay. Again, I told you before when uh, I practice dry coding. Right? Don't repeat yourself. If the technology exists, if the library exists somewhere out there that does exactly what you're looking for, then use that one instead of um, creating the code all over again from the beginning. Okay, that is very very rare. Okay? It doesn't happen that often in companies, right? If the technology exists, they're using that one. If it doesn't, that that's the time that they create it themselves. Okay. Chapter summary, slicing. Yep. So that's basically all that we have. All right. Let's see. Uh, it's almost 5. I wanted to finish this one. This is our third session, right? So in our fourth, I want to finish these two and probably go into web scraping. And on the fifth, we are gonna focus on pandas. All right. So that's our goal. Next week, first half will be these two PowerPoints, and then web scraping for the other half, and then if we can finish it, and then on the last session, fifth session is the Python pandas. We're going to be focusing on that. All right. I think we still have enough time for that to reach Python pandas. Okay. And of course, the extra hour that we were not able to take last week. So yeah. Did I miss anything? Okay. Before we end, is there any questions, clarifications? So we didn't actually have a lot of like coding activities, right? So I wanted to focus more on theories for now, okay? So that at least when we reach web scraping and then pandas, you won't get lost whenever I'm trying to say that this is the method, this is the function, this is the data type that we're working on, because it gets jumbled up a lot. Um, you know, at this point, when we reach this one, web scraping, the level of difficulty will go up. Like it will jump really. So be prepared for that one. So I'm not trying to scare you, but it will go up, right? Um, yeah, there will be a lot of information to take in, right? Again, practice, review our recordings. Um, if you have no questions, I think we can end early, 10 minutes early for today. So, yeah, that's it. I hope you guys enjoy your weekend. I'll see you next week. Goodbye.
Thank you.
Thank you.